Hi there and welcome to the first screencast of the workshops from Topic A. We're looking at workshop A1 today. So I'm just going to go into Topic A1, click on the link to workshop 1. Okay, so here's the workshop, and we can see that we're supposed to have R&R Studio installed, which of course I've already done. And now we're going to start by downloading our first R script. So I'll right click on there and save link as, and I shall pop it into the appropriate folder, and then I'll go into R Studio. So here we are in R Studio. What of course we see here is the console window on the left here, where we can type stuff in if we want, so we can execute code here if we like. We'll see in general we'll put our code in the editor window, which we'll see in a moment. This is our environment tab where we have all our data and whatnot will show up there, and then down here we have a selection of panels, one of which is files. We've got plots will show up here and helps over here and so on. Okay, so I'm going to start by opening up that file that we just downloaded, and here's our first R script. This is our editor window in the top left, and you can see here that I have some syntax highlighting, and that we've got some lines that are sort of in this orangey color, and then we've got some lines that are sort of darker, and a few special keywords have been highlighted every now and then. So the lines beginning with the hash, they're comments. Feel free to put comments through your code as you find it useful to you, particularly so that you can look back on it and sort of understand what you're doing. So that's when you should add a comment, as to, you know, if the code isn't particularly clear, or you just want to sort of document what it is that you're trying to achieve with the code that you're running. So we're going to run through the workshop. Let me get the workshop sheet up. I might make that a bit smaller and just pop it up here so that I can refer to it every now and then. Okay, so the first thing we're going to do is making sure it'll work. So we're just going to run these lines, run this line by line. So if I run this line, I just put my cursor on it and I can press the run button. Okay, and that'll transfer it down into the console window there, and I get some output, right? So I get a bunch of output about that it's attaching a bunch of packages, and I get some warnings here about conflicts. And what all this means is that when we run the filter command, it's going to be using dplyr filter, so the filter command from the dplyr package, we'll see what that is later on, instead of the corresponding filter command from the stats package, whatever these things are. Okay, so we've got two commands loaded that are both called filter, and it's masked one with the other, right? No big deal. This is pretty much exactly what we want anyway. We'll be using the filter command, but only the dplyr one. We may or may not use the lag one. Okay, so the next thing we do is we load the Quakes data with the data command Quakes, and you can see that it appears in the global environment here as a promise. And if I click on it, then I see the data. It's spat out down the bottom here. Okay, so it's a bunch of data on earthquakes, and so I've got the latitude and the longitude of where the earthquake was, its depth, its magnitude, and the number of stations at which that earthquake was detected. We can click on it in this data view here, and there it is there. So it's sort of a bit of a spreadsheet layout. And so we can see that if we go all the way down the bottom there, we have 1,000 entries. Okay. Right. And then the next line is going to be doing the plotting. So if I run those lines, I'm using Control Enter as a shortcut for run instead of pressing the run button. I could press the run button as well if I wanted to. So Control Enter is the shortcut on most computers. If you're on a Mac, it'll be Command Enter. So generally when I say Control, it'll be Command. I'm on a Linux machine here, so it controls the thing on my keyboard. But of course, if you're on a Mac, it'll be Command. So you can see here that we've created a plot, and there it is there. So this is the latitude and longitude locations of all of the earthquakes. So it's a map, right? Fiji's somewhere in here, and New Zealand's down the bottom here. Okay, so let's see what we're supposed to be doing here. Right. Okay, so we've done that, and now we're doing the plot. So one thing I will note is that the two parts here of the plot, the ggplot command and the geompoint command are the two main things that make up the plot, are joined together with the plus. And it's important that when we do this that we place the plus on the end of the preceding line and not at the start of the new line. So for example, if I change this and put the plus down here, then when I run this, it's not going to work, right? So when I run that first line, it's just ran the ggplot line, and when I run the second line, then I get an error. Unfortunately, in this case, it's actually told me some information. Did you accidentally put plus on a new line? And yes, I did accidentally put plus on a new line. What you'll find is as you do get errors, and you will get errors, I'll get errors here too as I'm running these screencasts. What you'll find is that many of the errors that R gives you aren't particularly useful. However, if you copy and paste them into Google, you can get some better context. In this case, we do have a useful error message. Kudos to the ggplot2 developers that they've found a common mistake and have made sure that the error message reflects the actual thing, right? So the error probably just used to be this line here, which doesn't make a lot of sense, but they've added this extra piece in to help clarify it. Okay. Right. So we're going to break down what's going on here. Right. So we've already seen what this first bit does. Right. The ggplot line with data equals quake produces a blank plot. Right. So the ggplot bit is producing the blank plot, and the data equals quakes is just associating the quakes data with that plot. Okay. The mapping piece Okay, what about the mapping piece? Right, so what happens if I run this line here? Well, seemingly nothing, right? There was nothing put out down here that didn't change our plot in any way. But of course, we note that we do have another thing up here, which is a list of two objects. If we click on that, we can see that there's some stuff associated with it. So inside mapping, there's an X and a Y. Okay, doesn't really tell us much. If we type out what it is, then it will give us the information that we want. So the mapping is an aesthetic mapping, which maps X on the plot to the column long in our data, and Y on the plot to the latitude lat in our data. So there's two main types of command that we have in R. So one of them is an expression. Let me put my phone on silent. Which is like this bit here. So if we just ran the AES bit by itself, so this is an example of an expression, right? And it's an expression is something that executes, it does something and spits something out. Okay, so it returns an object, and by default, any object returned by a function is printed to the console. So the object itself is printed. Okay, whereas this is an example of an assignment where we take the output from an expression, the AES bit, and assign it via equals to the object called mapping. Right, so when we run that command, it executes the AES bit, but instead of returning the output to the console so that we can see what happened, it saves the output into the variable or into the object mapping. and we can then use that object mapping later, for example, to print it out. Okay, so two main sort of thing. We've got an expression and we've got a assignment. Okay, and then the last thing, of course, is tying it all together. So the geom point bit creates a layer of points. So it's a geometric layer. So it's a layer of geometry in the form of points that could be added to a plot. Right, so if we do the geom point mapping equals AES, x equals long, y equals lat. Right, then we get an object that tells it that knows that it's supposed to do points. It's got some mapping and it's got some other information associated with it. So it's, for example, there's no transformation on positions and there's no statistics being done on those points before they're plotted. Right, so you can do lots and lots of very cool and interesting things with using the ggplot library. We'll be only really using it a tiny little bit really compared to what it can be. For example, you could do some summary of the data before you actually get to plotting. Okay, by for example mapping the statistic to use to be the mean, for example, instead of mapping all the points, it would map just the mean of the points, which probably isn't going to be much use. So bringing it all together, we get the original plot, right? I should really be copying and pasting, shouldn't I? Don't be afraid to copy and paste. They're the most powerful tools in the world. Okay. Just, of course, be a little bit cautious if you're doing it off Google. That it pays to sort of have some idea as to what the code might produce, so that you're not too surprised by the outcome, or that you can help, get it into the context that you're dealing with. Okay. Right, so now we're going to try adding to our plot by changing the colour. Right, so in this case, we've specified the colour as pink. Note I could use col, but I could also use colour. Okay, that also works. And I could also use the American spelling of colour, and that will also work. Okay, and we've also done size. So in this case, I've coloured the points pink, but you could choose other colours. They're a bit hard to see when they're pink like that, aren't they? Perhaps we could try dark pink and see if that's a colour. That's not a colour. Okay, what's a dark pink colour? What about, I guess we could do dark red maybe? Okay, so dark red works, but I'm thinking maybe some maroon. Perhaps maroon is dark red. Maroon, is that how you spell maroon? Yes. Oh, yeah, it's a bit more pinky. Okay, if you're interested in what colours are available, then you can just type colours. Okay, and run that, and you can see that there's 657 colours available, which sounds impressive, but if you scroll up a bit, a lot of them are grey, right, in two different spellings. So there's 101 shades of grey in two different spellings, so 202 shades of grey. Okay, so we've also altered the size here, and there's many other things that you can change as well. Okay, so just some notes. When specifying colour names or names in general for things on the plot, e.g. for plot labels, title, subtitle, x-axis label, etc. We use quotes around the string, the character string, word, right? So here I've used single quotes, right? So there's just one quote, right? But I could do the same thing with double quotes and it would still work as long as I start and end with the same thing. So notice when I just put a double quote there, everything after that is green because it knows it hasn't finished the string yet. And you can also see that we've got a problem in that we don't have we've got an unmatched opening bracket because that closing bracket there, which matches with this one here, is part of the quote at the moment, right? So that entire thing is part of the character string that I'm passing to color. So as soon as I close it off with a double quote, then it knows things are correct and my error messages go away. So that would give me the same plot as well. Okay. So there's lots of things that we can play around with. Let's do some experimentation. So to find all the colors, we can use colors. I'm not sure if the New Zealand spelling, oh yes, New Zealand spelling works as well. So that's nice. Okay. Right, so let's try some other stuff. So what else can we change here? We could change, so we've changed the color and the size. We could also change so let's make them a bit bigger. We could also change the shape. So we could change the shape to be squares. Okay, and we get squares. If you're interested in finding out about the different shapes, then I'll show you that in a moment. Essentially what we do, let's show you it now actually, shall we? Let's look up the help for GeonPoint. If we look up the help for GeonPoint, and I'm doing this by pressing F1 while hovering over GeonPoint, while I've got my cursor on GeonPoint. Alternatively, I can type, so finding help on GeonPoint, place cursor on function name and press F1 or type in front of function name. So I could do GeonPoint like that, right, and run that, and then I get the help. And so it's got lots of stuff, like, you know, all the arguments that GeonPoint can take. So notice the very first one is the mapping argument, which is what we're passing, and there's lots of other stuff. The ... is rspeak for other stuff. Okay, so anything else goes in there. So for example, the color and the size and the shape have been all sort of filtered through the ... argument there. And if we go down a bit, then we can find the aesthetics that it understands. Right, so you can see that X and Y are required because they're bolded. If I don't have them, I'll get an error. Let's check. So if I take that away, then I get an error. It tells me that I'm missing Y. Okay. But I can have alpha, color, we've used that. Fill is for the inside of the point. So a point essentially has an outside surface or outside sort of like an outline, which is what the color generally is about. And then it has a fill color, which is the inside. However, some of the shapes only have an outside. So for example, the default shape that we're using here and the square shape only have an outside, so that when I specify the color as maroon, the whole thing's shaded in. And if I specify the fill as maroon, nothing will change, because those shape types only have an outside, not an inside. So I'll change that back to color. What else? Group, we'll see that later on. Essentially that allows you to break things into subgroups, so you can do your geometries per subgroup. Shape we've seen, size we've seen, stroke. So stroke is about the outside of the outline. Okay, so the shapes that do have an inside and an outside, such that fill and color work. Then the sort of the border is made up of a bunch of line segments which have some certain width. That's what stroke is. Okay, and it says you can learn more about setting these in this vignette. So what we're going to do is we're going to copy that code. We're going to run that, and what we get is this document on the aesthetic. So it tells you all about how to set color and fill. So for example, you can have a color red and it has 657 built-in named colors, which you can find using colors, or you can specify it with an RGB specification of this form here, or you can do transparency with this form here, NA for completely transparent, and there's a bunch of other packages that will give you colors. So the Munsell package is one, but there's lots and lots of other packages that are just for providing colors. Tells you a little bit about lines and different line types. So these are useful for doing line graphs, right? The size, how the lines end and join together. All of this can be changed. Polygons, points, shapes. So here we go. So shapes can take 5 types of values. So it can take an integer. So for example, we can say shape equals 2, which turns out to be an open triangle. Okay. Or we can use the name of the shape. So let's copy and paste that in. Right, and run that. Okay, so it's an assignment operator. So we've got a new object called shape names there. So if we type shape names, we'll get them output. So these are all the different names we can have. So the default is a circle, but there's a circle open, a circle filled, and so on and so forth. And some of these filled ones are the ones that you can specify the color inside and outside differently. Usually I find that that's a little bit too busy, but anyway. Okay, so there's where you look to find all of the information on aesthetics. Now, going back to our plot. So one thing we notice is we've got a lot of, so let's maybe get the shape back to how it was. Right, just use size and color. But one thing we note is that a lot of the points are on top of each other here, right? So we can't really tell how many points are in this area. It could be just enough to sort of so that they overlap with each other, or it could be many, many hundreds more that are sort of on top of each other, and we don't know. So we can't tell from this plot where the points of highest density are, because of the fact that all of the points are opaque, and we can't tell how many points are underneath, right? So potentially on this point here that looks like just one point, there could actually be a stack of 100 earthquakes, right, that just happen to be in the same location, and they're all stacked up, but we just can't see them because they're not, they don't have different X and Ys. So a useful thing to do whenever you have overplotting, and in fact it was hinted at, I think, in the back here, there's a whole section on overplotting, is some option. So for example, another technique is to make points transparent, i.e. add some alpha. So the alpha argument is for transparency. So maybe I'll write this. We'll do another, adding some transparency to reduce overplotting. So we're going to go alpha equals 0.5. So 0.5 would be half transparent. Okay, so alpha takes a value between 0 and 1. Okay, so 0.5 is basically half see-through, if you like. The smaller it is, the more see-through it is. So 0.1, it's very see-through. You can see that actually there seems to be a fault line through here, right? So this runs up the side of Fiji. I think Fiji is around here somewhere. So this runs up the side of Fiji. Okay, and of course, if we want to darken them up, we can use a bigger number, right? So 0.9, it's hard to tell, but these are very slightly transparent. I think you can maybe tell on these points here. So slightly lighter ones there. Okay, it's perhaps a little bit more obvious there on the video. Okay. Right. Okay, and in the same way that we've changed these things for all points by setting them, i.e. putting them outside the AES command, we can also change these things based on the data, put it inside the AES. Right, so if instead we want to color by magnitude, then we could use the magnitude column in the data, right, MAG. Get rid of the color equals maroon, because otherwise everything will be maroon again. Maybe add a little bit more alpha, although that's not too bad. There we go. And we can see it's a little bit tricky with alpha and a color range. Perhaps I'll dial it back a bit. There we go, that's a bit better. And you can see now that each of the points is colored differently depending on its magnitude, right? And so because the magnitude is just a bunch of numbers, right? It's a continuous measure. It's given us a continuous color scale or a gradient, right? So the lighter colors are the bigger earthquakes, the darker colors are the smaller ones. So you can see here that these ones here are the big ones, whereas a lot of the ones that are down this this area where there's many earthquakes, a lot of them are quite small. Okay, we've got some bigger ones down here as well. Okay, notice that so there's a difference between these two as to where I put the color argument. So here, because color's been taken from my data, it goes inside the AES, right? If I try to do that outside, so if I try and assign a column in my data to the color variable, then I'll get an error that mag is not found, right? So it's got to be inside the AES so that it knows to look inside the data frame quakes in order to find that variable. Okay, so there's only a few functions, AES is one of them, that knows to look inside the data frame for that thing. Right, so if it comes from the data, it goes inside the AES. If it's set for everything, it goes outside the AES. Right, so the size is 3, the alpha is 0.8, it goes outside the data frame because we are setting them the same for all points. Okay, if we instead color by station, right, which was another column in our data set, or stations, got to get it right. Let's see what happens if I get it wrong. I get an error, right? Object station not found, because I spelt it wrong. You'll probably spell things wrong quite often. I do anyway. So when you get error object not found, it's almost certainly because you made a typo. Sometimes it's because you haven't loaded the data, but that's it. And so you can see that if you actually compare these two plots, there's an empty one. Let's get rid of that. Oh, no, we don't want to clear all of them. Okay, so that button there to get rid of one, that button there to get rid of all of them. There we go. So here's the one with magnitude, and here's the one with stations. Right, and you notice that it's actually quite hard to tell the difference between these, isn't it? There's a little bit of difference up in here in terms of the shading. A little bit of difference in terms of the shading, but the general pattern is the same, isn't it? And that should make sense to you, I think, because the lighter colours here, of course, are the big earthquakes. And the lighter colours here are the earthquakes that are felt at many stations. And of course it makes sense that the earthquakes that we feel at many stations will be the big ones, right? The exceptions might be, I guess, if there's lots of stations around an area where there's, lots of small earthquakes, then all of those stations are probably going to pick them up. But the general trend, of course, is the same. Okay, so let's just add a wee comment. As larger earthquakes, high magnitude will be felt at more stations. Okay. Right, so that's pretty much it. Next time we'll look at more plotting with ggplot.